Hi everyone, welcome to my channel. My name is Alyssa and I'm a medical laboratory technician currently working on my bachelor's degree to become a medical laboratory scientist. I study online and the best way I learn is by teaching and explaining concepts out loud. So this channel helps me study and hopefully helps others learn too. This video will be part of a series discussing urinalysis. Urinalysis is usually one of the first topics we learn as lab techs, so I felt it was the most logical thing to do to start a series on urinalysis first. So let's dive right into it. Imagine being a doctor in the early 1800s. Patients keep coming to you with swollen legs, faces, and bellies. They are so full of fluid that they can barely even move. This condition was called dropsy, what we now call edema. One physician named Richard Bright wanted answers. When he examined these patients after death, he noticed something strange. Their kidneys were shrunken and granular. And what he means by granular was that upon gross examination or just visual examination without the use of a microscope, the kidneys of these patients were grainy, or they were uneven, or they had like a sand-like texture. And it was not like that on other patients where their kidneys were more smooth to the touch. Bright made a groundbreaking connection. Edema wasn't just a fluid problem, it was a kidney problem. So, how could damaged kidneys cause the body to swell like that? To answer that, we need to understand what exactly the kidneys do. By the end of this video, you will be able to describe the importance of the kidneys' functions in maintaining homeostasis in the human body. Our kidneys are small, about the size of our fist, but they work non-stop to keep our internal environment stable. Every minute, they filter blood, adjust its contents, and return it to circulation in perfect balance. This stability is called homeostasis. Now, let's break down how the kidneys make that happen. So the first core function of the kidney is blood pressure regulation. The kidneys help regulate blood pressure in two major interconnected ways, and both of them come down to one big idea: how much fluid is in your bloodstream. First way is through electrolyte and water balance. Think of sodium as the bossy electrolyte, where sodium goes, water follows. The kidneys constantly decide how much sodium to keep and how much sodium to excrete in the urine or remove from the body. When the kidneys hold onto sodium, water stays in the bloodstream to dilute it. This increases blood volume, which pushes more force against blood vessel walls, aka raising blood pressure. On the flip side, when the kidneys excrete more sodium, water leaves with it. Blood volume drops, pressure inside the vessels decrease, and blood pressure goes down. So even small changes in sodium handling by the kidneys can have a big impact on blood pressure over time. The second way is through the RAS, or the renin-angiotensin-aldosterone system. The renin-angiotensin-aldosterone system, or RAS, kicks in when the kidney sense trouble, like low blood pressure, low blood volume, or low sodium levels. Special cells in the kidney release renin, which starts as a hormone domino effect. So, firstly, renin ultimately leads to the production of angiotensin II, which is a powerful vasoconstrictor. Okay, so that means it tightens blood vessels. And when that happens, blood pressure increases. Second, angiotensin II also triggers the release of aldosterone, which tells the kidney to reabsorb more sodium. Water follows that sodium back into the bloodstream and then it increases blood volume even further. So the renin-angiotensin-aldosterone system also stimulates the antidiuretic hormone, or ADH, and this hormone encourages the kidneys to reabsorb more water. So what is the result after all this? Okay, more sodium, more water, tighter blood vessels, so vasoconstriction, equals higher blood pressure. So why does this matter clinically? If the kidneys overactivate RAS or retain too much sodium and water, blood pressure can stay chronically high, leading to, you guessed it, hypertension. If they can't conserve sodium and water effectively, blood pressure can also drop too low, which is called hypotension. This is why so many blood pressure medications like diuretics, ACE inhibitors, and ARBs target kidney function. So, to sum it up, the kidneys control blood pressure by deciding how much salt and water stay in your blood, and by flipping on hormonal systems when pressure gets too low or too high. The second core function of the kidney is the removal of metabolic wastes. Every cell in our body produces wastes. The kidneys filter out urea, which is a waste product from protein metabolism, creatinine, which is also a waste product from muscle metabolism, and the kidneys also filter out excess electrolytes and toxins or drugs. Without this constant filtration, waste products would quickly reach toxic levels. The third kidney function is to maintain our pH balance. Our blood pH must stay within a very narrow range to sustain life, and the kidneys help by excreting hydrogen ions and reabsorbing or producing bicarbonate. This fine-tuning keeps our blood from becoming too acidic or too alkaline. Additionally, the kidneys don't just filter, they also act as endocrine organs, meaning they release hormones. The hormones that the kidneys produce are renin, erythropoietin, and also the active form of vitamin D called calcitriol. So renin, it's part of the RAS, or the renin-angiotensin-aldosterone system, and this hormone regulates blood pressure and blood volume. Erythropoietin, or EPO, stimulates red blood cell production in the bone marrow. This is also why chronic kidney disease often causes anemia. Lastly, the active form of vitamin D called calcitriol helps the body absorb calcium and phosphorus from our food, and it's critical for strong bones. This is also why some people with kidney problems end up having weak bones. To summarize, the kidney's core functions are blood pressure regulation through electrolyte and water balance and the system called RAS. The second one is to remove metabolic wastes such as urea, creatinine, or any other excess electrolytes, toxins, or drugs. The third one is pH balance by removing any excess acids or alkali from the body. And the last one is hormone production, such as producing hormones like renin, EPO, and calcitriol. Okay, so I decided to add some fun historical facts here in these videos because, at least for me, these fun historical facts really help me study, and they make things a little bit more memorable, so I'm gonna just add little tidbits here and there. Before Richard Bright, people didn't really understand what the kidneys did. They just knew that urine came out eventually. Some early theorists suggested the kidneys simply stored urine, kind of like biological water bottles. Others thought they helped cool the blood because ancient medicine was very into balancing heat and fluids, balancing the humors. And many believed the kidneys played only a minor role, acting as passive waste holders rather than active regulators of the body. Urine testing, though, that's been around for a very long time, and it got pretty creative. In ancient times, one pregnancy test involved soaking barley or wheat seeds in urine. If the seeds sprouted, congratulations, you were pregnant. Surprisingly, this test was actually fairly accurate by modern standards. Later on, doctors turned to frogs. When a woman's urine was injected into a female frog, the frog would release eggs if pregnancy hormones were present. Crude? Absolutely. A little unhinged? Maybe. But it worked, and it laid the groundwork for modern hormone testing. So while early medicine didn't fully understand the kidneys, they were already onto something important. That urine tells a story. So up next, I added some challenge questions just to make this a little fun and to kind of test your recall. So feel free to pause this video anytime and see if you remember some things. So back to Richard Bright's patients. Why the swelling? When kidneys fail, they can't properly regulate fluid balance, blood proteins, or blood pressure, leading to fluid leaking into the tissues, which is called edema. So what else can go wrong in the kidneys? How do we test for kidney disease? How do doctors know when kidney function is declining? We'll cover all of that in future videos. But next up, kidney anatomy. Where does urine production begin and where does it end? Thanks for watching, and I'll see you in the next video.